Thank you, everyone. Like Serena said, I am Josh Andrews. I am our nutrient management agrologist at the Ministry of Agriculture, Food and Fisheries. Today I'm going to talk about soils and pH, and I'm going to mostly focus on the central interior, but a lot of the stuff I'll say about pH is applicable to everywhere. So hopefully you'll find some use from it. So I know I only have 20 minutes, but what I want to do in this presentation is just give a brief intro to pH, talk about the pH effects on crop growth and nutrient availability, talk about the things that affect soil pH, how it's determined, what to do if you have a low pH, and how to raise pH. So starting off, pH is actually a mathematical expression. So it is the negative log of the hydrogen ion concentration. But of course, we're not in school, so for a lot of you, that really doesn't mean a lot. But essentially, it boils down to it's a measure of how acidic or basic your soil is. And I'm sure most of you know that this ranges from 0 at the low end to 14 at the high end. So anything from 0 to about 6.5 in your soil would be considered acidic. Roughly 6.5 to 7.5 would be considered neutral. And then anything over 7.5 would be considered basic. And the reason we worry about soil pH is because it affects your crop growth and it affects how many of the nutrients in your soil are available. So I'm sure most of you have seen a similar thing before for the pH scale. But like I said, it's 0 to 14. On the right side, you can see some of the common acids and alkalis. So vinegar or coffee is about around 3, and then rainwater itself is actually kind of acidic. It's at around 5.5. Pure water, of course, is neutral, but then bleach, milk of magnesia, these are all alkaline things. But on the left-hand side, it has the soils, and so in BC we have a lot of forested soils, and so their pH is normally in the 3.5 to lower 5 range. So they're quite acidic. But most of the soils we use for agriculture, which we would say they're in a humid climate, if they receive, a non-insignificant amount of rainfall, are usually around 5.5 to 7. And then calcareous soils that have a lot of calcium carbonate in them, they're usually a little bit basic. They're usually a little bit above 7. And then sodic soils, which have tons of sodium, are usually pretty high. So going on, your soil pH is normally based on the material the soil was formed from. And then the climate and the vegetation that's grown in that soil will affect the soil pH over time. And so drier areas tend to be more basic, and then wetter areas tend to be more acidic. And so in an older publication, I found that we have about half the soils in central BC are acidic. So Prince George, Smithers, and McBride, those tend to be more acidic than the soils in Vanderhoof, Quesnel, and Williams Lake. And then, of course, in the lower mainland, where we get a lot of precipitation and there's a lot of agriculture, those soils tend to be acidic based on the way we treat them. So one of the things we worry about with pH is it in a range that the crop likes? Because most crops really only like to grow in certain pHs. So at the very top, you can see berries. So blueberries are an interesting crop, but they like really, really low pHs. So if it's above 5.5, they really don't grow well. But for our purposes, we're talking about forages. Most grass forages do pretty well around 5.5 up to actually kind of basic pH. And then alfalfa, which is a big forage species, it has a little higher preferences. So normally, I know this says 6.5, but normally around 5.8 or 6 is what's the lower threshold for alfalfa. But of course, there are other legumes you could grow, like crimson clover or vetch, that can tolerate acid soils a little better than alfalfa can. And I don't want anyone to be mistaken that, if it's 1 point off, the preference that the crop will just shrivel up and die. They tolerate different pHs that are outside their favorite range. They might just not grow the most effectively. And so another thing we worry about with pH is how available are the nutrients. So I'm sure you've also seen this figure before, but this basically just shows how available nutrients are at certain pHs. So you can see a lot of these nutrients, or at least the first half of them, aren't very available at low pHs, but some of the other ones, that's the only time they're available. So if you notice, I've drawn a line around 6 to 6.5. So that is the area where nutrients are most available for your crop. So normally, when we talk about soil pH and what our preferences are, if we keep in that range, most crops do well in that range, and then nutrients are the most available. So when you start getting into lower pHs, like we saw in that image, nitrogen isn't very available because it limits the bacterial activity. So nitrogen is a nutrient that is mostly driven by bacteria. So if the bacteria can't operate, it's hard for that nitrogen to be available. Phosphorus is an interesting nutrient at low pHs. It does not become very soluble to plants, and it's instead fixed to iron in your soil. Potassium, it's not held very strongly by your soil particles, which of course are negatively charged. So it's harder for it to stay available to the plant. And then of course the micronutrients you saw, they're actually more available, but they're not normally the limiting factor in plant growth. So I wouldn't make my pH low just for micronutrient availability. So what affects our soil pH? A big thing that affects your soil pH is this process called nitrification. And so it is this bacterial process where ammonium is converted into nitrate. So ammonium and nitrate are both forms of nitrogen that are plant available. And so when your soil is warm and moist, these bacteria will take ammonium and it will turn it into nitrate. And this is actually a very acidifying process. And usually this happens because people will continue to apply ammonium-based fertilizers. So one way to prevent that before it happens is to, if you have it available, apply a nitrate-based fertilizer. So something like calcium nitrate or potassium nitrate. But of course, that's not always available. And then of course, lime, which most of you have hopefully heard about before, is used to raise your pH. And one thing I didn't put on here was elemental sulfur. So that is actually used to lower pH, but it can be kind of expensive and it's not something that you can really do on a big scale. So I normally don't really bring up sulfur when we talk about soil pH. So what doesn't affect soil pH? So sometimes people are mistaken that it's the calcium in lime that is what raises the pH, but it's actually the carbonate in lime, which is calcium carbonate. So things like gypsum or calcium chloride will not change the pH, but they are good sources of calcium. Fertilizers that aren't N-based, usually phosphorus and potassium fertilizers, don't have too much of an effect on pH. And then tillage. A lot of people mistakenly think that, you know, when you aerate the soil through tillage, that's actually will change the pH. But really what happens is you have different levels of pH in your soil. And then when you combine those, it kind of just evens out and averages out over two different layers. So to determine your soil pH, if you've ever heard me give a presentation before, I probably brought up soil testing. But if you want to determine your soil pH, that's what you got to do, is you have to go out and you have to take some cores and send them into the lab. And so when you're doing this, you want to make sure you're sampling areas that are the same. They want to have the same soil, they should have the same crop on them, and they should have received the same fertilizer. So if they got a different nitrogen fertilizer, or if you did a different nitrogen rate, it's probably a different pH because, as I mentioned before, ammonium fertilizer affects soil pH. So even if you applied the same fertilizer, say something like ammonium sulfate, but if you did 100 pounds per acre on one field and 50 pounds per acre on 100 field, that's a different amount. It's going to affect your pH by a different amount. So make sure you separate those out when you're sampling. And so it's always a good idea to sample at the same time every year because your pH actually changes about a quarter point throughout the year. So if you were to take a sample in the spring and take a sample in the fall, you actually will have a somewhat different soil pH, even though not a whole lot has changed. And so I'm sure you've seen on some soil test reports where they have two different numbers and you probably thought like, okay, so which one do I use? So there's normally two ways that soil pH is normally reported. So the first way, the most common way, is your soil pH in water. But the second way that a lot of laboratories do now is in a calcium chloride solution. And the difference is when soil pH is measured in water, it's around a ½ point higher than in calcium chloride. But salts can affect the measurement in water, so the calcium chloride is used as a stabilizer. So in calcium chloride, it's more consistent, but you need to adjust that number because it's going to be artificially low. So which one do you use? Our recommendation is to take the pH in calcium chloride and multiply it by 1.1 to get the water equivalent pH. So some people recommend add ½ a point, add 0.6 of a point, but our recommendation is to multiply it by 1.1. So if you had a pH of 5.5 in calcium chloride, that would give you 6.05. For 6, it would go to 6.6, and then 6.5 would go to roughly 7.2. If you only see one number, or if you see two numbers and you can't tell the difference, it's always a good idea to ask the lab. That's their job. You paid them to do your soil test report, and they should tell you what they did. So moving on to low pH. In agricultural soils, that is our biggest issue with pH, is that it's too low. I have heard that some people say, well, my home garden is consistently like an 8, 8.5. And I have noticed that home gardeners really like to apply wood ash. And I mean, it is a good source of nutrients, but it's also pretty alkaline. So it can raise that soil pH a lot. And I think a lot of home gardeners don't really worry too much about the rate, so they could be applying a fair bit. So what happens if your pH is too low? As you saw in the figure before, there are less nutrients available, and then it's outside of that crop preference. And the crop just really doesn't function as efficiently as it could at that point. And it's not fatal, like I said, it's just a little bit reduced than what its full potential is. And then when you go even lower to a pH of around 4.8 or 5, soil aluminum becomes soluble. And this is actually toxic to plant roots. So this is the point where you really can't grow anything. And some of the symptoms are drought stress and stunted growth because, of course, the plant can't take up water and it can't take up nutrients. So this image at the bottom is a microscopic picture of some plant roots. The one on the left, that root is fine, it's growing at normal pH. And then on the right, there's a root where the pH is too low and it's turned into kind of a club because every time it interacts with aluminum, it kills it and it kind of dies back and it turns into basically a club root. So this image is showing something similar. On the left, we have, these are barley seedlings that were grown in a pH that was about 5.6, and you can see that the aluminum concentration is less than 2 parts per million here. So there's not a lot of free aluminum to damage these roots. And then in the top right, you can see some roots that had a pH of about 4.4, and at that pH, aluminum is more soluble, and it can kill those plant roots. So always something to be looking out for. Another thing to remember to low pH is that forage grasses do better than alfalfa. And that's because alfalfa uses a soil bacteria known as rhizobia. They form this relationship in the roots and form nodules, and that's what helps the alfalfa plant fix nitrogen from the atmosphere. Those rhizobia don't do too good when the pH gets too low. So when you get to about 5.8 or below, it's when they start to be affected. And at that low pH, they don't survive as well. And then it also restricts further nodule formation. So basically a thing to keep an eye out if you grow something like alfalfa. But of course, I think the question we saw earlier is, what if lime is really expensive or I don't have access to it? Then a thing to think about is using acid tolerant crops, as long as you can keep your pH at or above around 5.5. So if you are trying to grow legumes in your forage mix, and of course your pH is lower than 5.8, you can't grow alfalfa. Some good other options are all-site clover, red clover, or bird's foot trefoil. And then grasses, most of them normally do okay when you're above 5.5. And then if you're using a grain crop as a forage, oats are normally more acid tolerant than barley. I couldn't really find a hard number for that, but I would assume it's probably similar to alfalfa, around 5.7 or 5.8. So raising pH, of course, we raise pH with lime. So in the Lower Mainland, we want to do this around every 3.5 to 5 years, and really that's just because the intensity of cropping that goes on there. There's a lot of ammonium fertilizer used, and there's a lot of rainfall, and of course rainfall has a slightly acidic pH. But in the interior, really just as needed. So normally there's two different types of lime you can get: agricultural lime, sometimes called ag lime, or its mineral is actually called calcite, but this is calcium carbonate. And then the other form of lime is dolomitic lime, or its mineral is called dolomite. So it is calcium carbonate and magnesium carbonate. And lime raises pH through a chemical process. So you take the calcium carbonate, and these hydrogen ions are neutralized, which are causing the acidity. And that reaction just basically creates water and carbon dioxide gas. And there are definitely other things you can use to lime your soil. Of course, I talked about limestone and dolomite. There is hydrated lime, and there's also burnt lime, which is also called calcium oxide. And then there are a fair amount of byproducts out there that you can use to raise pH. So sugar beet lime, of course, there's not a ton of sugar beets grown here in British Columbia. Paper mill lime, sometimes cement dust, and then different wastes, so like shrimp and crab waste. So I know Dieter has talked about this a little bit before, but when you're applying lime, a thing to consider is the buffering capacity of your soil. So the buffering capacity is the ability of your soil to resist changes in pH. So it's lower in coarse soil and it's higher in fine soils, and it's related to your cation exchange capacity, which is similar. And there are different tests to determine the buffering capacity. You may have seen these on soil test reports. Norm, I guess I could ask you at some point what your lab uses, but the S&P buffer method was one that was used for a long time. That's kind of been phased out. It used some chemicals that aren't the best. There's the Sakura method, and then there is the lime buffer test. And so this is an image from some central interior liming trials that took place in the 80s. And so the two I want you to look at are the Pine View and the Saxton. And notice these two have two different soil textures, the clay and the sandy loam. And so like I said before, clays have a higher buffering capacity, so it's harder to change their pH. So to go from the pH of 5 to their target pH of 6, which is in that middle column, it took 5.4 tons per acre to raise it, just 0.5 of a point. But in the sandy loam, which has a lower buffering capacity, it started at 5.6, and for it to go up a similar amount, it only took 1.3 tons per acre. So definitely it is different for different fields. So my recommendation would be, if you can get a lab to tell you what the buffering capacity of your soil would be, you could really dial in how much you need. And then another thing to think about when you're trying to lime your soil and raise your pH is the type of material. So one thing to think about is the calcium carbonate equivalent. So it's basically a measure of how effective this material is compared to ag lime, calcium carbonate. So actually a lot of materials are more effective than calcium carbonate, excuse me. So most effective, of course, is calcium oxide, but dolomite, which has magnesium in it, is more effective, and then slag is considered the least effective. And then another thing to think about is the fineness of the material, because the smaller particles have a greater surface area, so they have more reactions with the soil. So if you are buying lime, look at the fineness factor. So they may tell you what mesh size of a screen that material will fit through. And so usually the higher number means it's a finer mesh, so it means it's a finer material. One thing to note about lime is that it has a low solubility, so it does take time to raise your soil pH. It is faster if you incorporate it because there's a greater surface area that's in contact with the soil. But it's also effective when it's surface applied. It just takes some time. I will say if you're going to apply more than 3 tons per acre at a time, you might have to do split applications, or else you're just applying too much on the soil surface. So I'm nearing the end here, but the last thing I want to show you is in those central interior liming trials, when they increased the soil pH in a lot of these soils, they did see an increase in alfalfa growth. And so their average was about 0.5 ton per acre, which to me is pretty significant. And so, of course, that's because alfalfa likes higher pHs and also because nutrients are more available. And so I think I'm within my 20-minute window. So I think now would be the time for some questions.